With prayers to Ma Sharda, we will start again understanding principle of superposition. Today is a special day. It is Adhya Shankaracharya Jayanti, so very auspicious day. Yesterday we discussed about principle of superposition. It is about when many charges offering electric force on a single charge, what will happen? That is called principle of superposition. Okay, principle of superposition states that the resultant force on that charge will be equal to vector sum of electric forces exerted by all other charges. Yesterday we have taken example of only two charges offering force on a single charge. Now today we are considering total 5 charges. Okay, there are total 5 charges: Q1, okay, then Q2, then Q3, then Q4 and Q5. We are considering 5 charges today, system of 5 charges, 5 point-like charges, and we have to find out the resultant force on Q1 today. Okay, resultant force on Q1 by other remaining charges, that is force by Q2, Q3, Q4 and Q5. Force is a vector quantity, so first of all we need position vectors of all charges. We have not mentioned here position vectors, but this is the reference point, okay, O. As in order to avoid complicated diagram, we have not drawn here vectors. Okay, vectors of position vectors are not shown, arrows are not shown. Okay, but this is the reference point with respect to which we have taken position vectors of Q1, okay, Q2, Q3, Q4 and Q5, and we have not drawn here. Okay, now first of all, what is the force on Q1 by Q2? That is called F12. That will be repulsion, because we have considered here like charges, and like charges offer repulsive force. So this Q2 will offer repulsive force, that is F12, force on 1 by 2. This is the vector showing F12. Okay, then this Q3 will also offer repulsion, that is force on Q1 by Q3, that is F13. Okay, so these two are the vectors. Now first of all we will make sum of them according to parallelogram law. Okay, so these two are the sides. Complete a parallelogram. This is diagonal, this is diagonal. That gives us resultant of F12 and F13. This vector gives us resultant of F12 and F13. Okay, now force on 1 by 4. Force on 1 by 4. Okay, so it is again repulsion. So F14. Okay, this is the vector. Now we have to add this F14 and resultant of F12 plus F13. This. Okay, so again we are preparing a parallelogram here. This side is parallel to this, and this side is parallel to this, and this is the diagonal. This will be the resultant vector of actually forces F1, F12, F13 and F14. Now only we have to add F15. F15, that is force on 1 by 5. Again repulsion. Now I have to add this and this. Okay, so preparing a parallelogram, these are the parallel sides and this is diagonal. This is the resultant force on Q1 by Q2, Q3, Q4 and Q5. Again, let us understand this figure, which is somewhat complicated. Whenever you draw this figure, you draw somewhat large. Okay, don't try to draw a small figure, draw a large figure. Again repeating, this is the reference point. We are not showing position vectors. These are the charges Q1, Q2, Q3, Q4, Q5. We have to find out force on Q1. First of all, force on Q1 by Q2, that is F12. Force on Q1 by Q3, that is F13. Making sum of these two by preparing a parallelogram, This is resultant of F12 and F13. Now force on 1 by 4, that is F14. Okay, then add these two by parallelogram method, you will get this diagonal. Okay, then force on Q1 by Q5, that is F15. Again repulsion. Now we have to add these two. So parallel. Draw a parallelogram. Okay, these two are the sides, adjacent sides. So this will be parallelogram and this will be diagonal. That is the resultant force on Q1 by Q2, Q3, Q4 and Q5. Now formula. In system of charges Q1, Q2, Q3 up to Qn, force on Q1 by all other charges can be given as F1 equals to F12 plus F13 up to F1n. Okay. Now we know that F12 equals to K. In place of K we write 1 upon 4 pi epsilon naught into Q1 Q2 upon R12 square into R12 cap. But this 1 upon 4 pi epsilon naught is common in all the forces. So taken out of the bracket. So F12 is Q1 Q2 upon R12 square into R12 cap. F13 is Q1 Q3 upon R13 square into R13 cap plus dash 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 up to Q1 Qn upon R1n square into R1n cap. Okay. Now see, here Q1 is common in all terms. So taking out, so Q1 by 4 pi epsilon naught, Q2 upon R21 square R21 cap plus Q3 upon R13 square R13 cap plus Qn upon R1 square R1n square R1n cap. This can be written as there are so many terms. This can be written in form of sigma. Okay. So Q1 upon 4 pi epsilon naught, sigma of Q2, Q3 can be denoted by Qi upon R1i whole square into R1i cap, where I is from 2 to n. I equals to 2, I equals to 3, I equals to up to n. Okay. So yesterday we discussed that the electrostatics is actually a consequence of Coulomb's law and principle of superposition. Okay. So prepare this.